Welcome to Daily AI and Machine Learning Lessons. I'm Blake.
And I'm Jude.
Today, we're embarking on a deep dive into the foundational types of machine learning.
That's right.
Our mission is really to dissect the core ideas behind how machines learn, how they adapt from data, not just following orders, but actually learning.
Exactly. And you'll find there are basically three main ways they learn: supervised, unsupervised, and reinforcement learning.
Right.
So our goal today is to break these down for you, make them easy to grasp, but also touch on, the real world side of things.
Okay, let's kick off with supervised learning then. I find it helpful to think of this one as, well, learning with a teacher.
That's a great analogy because what's key here is the labeled data set the model gets.
Labeled data.
Yeah. So every example, say an image, already has the correct answer attached. Like this picture's a cat, this one's a dog. And the model's job is to learn the pattern, the mapping, from the input features to that correct output. It could be for classification, like identifying objects, or even regression, like predicting a price.
And you can really picture this, can't you? Imagine teaching a computer about fruit. You show it photos, apples, bananas, oranges, and importantly, you tell it which is which.
Uh-huh.
So it learns, okay, red, round, that's probably an apple. Yellow, curved, banana. But something we maybe don't always think about is the massive human effort behind creating those labels, right? That hidden work.
Oh, absolutely. That labeling process is often a huge undertaking. And while supervised learning is everywhere, think spam filters, medical imaging, translation, it does have challenges, like the cold start problem.
Right, what do you do when you have a totally new task, no labels yet?
Exactly. Getting started can be really costly and slow things down.
Okay, so what if you don't have those labels? What if there's no teacher?
Well, that's where unsupervised learning comes into play. It's more like exploration.
Exploration. Like letting a kid loose in a room full of toys, maybe. Or that fruit stand example, but this time, no signs. Just a big pile of fruit.
Precisely. With unsupervised learning, the model gets an unlabeled data set. No answers provided. It has to find patterns, structure, relationships within the data all by itself. It's about discovery.
So back to the fruit pile. Without any labels, the machine might start grouping things.
Yeah.
Maybe through clustering.
Exactly. Clustering is a key technique here. It would group fruits based on similarities. It finds maybe shape, maybe color, texture, things like that. It identifies these groups, these clusters, without ever being told what an apple or a banana is. It finds the categories itself.
Fascinating. So it's discovering hidden structures.
And that's incredibly useful. Think about businesses wanting to understand their customers. They can use this to find natural groupings or market segments. Or in cybersecurity, finding weird, unusual patterns that might signal an attack. That's anomaly detection.
Makes sense.
But the challenge is, since there are no right answers given, you have to figure out if the patterns it finds are actually useful or meaningful for what you're trying to achieve. Interpretation is key.
Okay, that covers supervised and unsupervised. What's the third type?
The third one is reinforcement learning.
Yes. The dog training analogy often comes up here. Rewards and penalties. But it feels fundamentally different from the other two, doesn't it?
It really is. Because here, the model, or agent as it's often called, isn't just given a static data set. It actively interacts with an environment.
Interact.
Yeah, it takes actions. And based on those actions, it gets feedback, sometimes a reward, sometimes a penalty. The whole goal is to learn a strategy, a policy, to maximize the total reward it gets over time, not just for one decision, but for a whole sequence.
Okay, the classic example is teaching a computer chess, right? It makes a move, and the feedback is just win, lose, or draw. But how does it get from that to playing like a grandmaster? It can't just memorize every game, surely.
No, definitely not memorization. It's much smarter. It learns through, well, massive amounts of trial and error. It explores different moves, sees what works, what leads to better outcomes down the line. It refines its strategy, its policy, based on that accumulated experience.
Those learning sequences of actions.
Exactly. Optimal sequences in really complex, changing situations. That's why it's so powerful for things like, say, autonomous driving, where the car has to constantly make decisions, or robotics training a robot arm to pick something up precisely.
Right, dynamic environments.
But it's worth noting, this kind of learning can require enormous amounts of data and computation. Training these models can be very intensive.
Okay, so let's pull this all together. If you had to summarize the core difference between these three,
Yeah.
what would you say it boils down to?
Well, fundamentally, it comes down to the data and the learning signal.
Okay.
Supervised learning needs labeled data. The signal is the known correct answer. It learns to predict outcomes. Unsupervised learning works with unlabeled data. The signal is sort of inherent in the data itself. It learns to find hidden patterns or structures.
Right. Discovery.
And reinforcement learning. It learns from interaction with an environment. The signal is the reward or penalty feedback. It learns to make sequential decisions to maximize that long-term reward.
Labeled data for prediction, unlabeled for patterns, and interaction for maximizing rewards.
That's a great way to put it. Each has its own strength, its own place, and often you see them working together in more complex AI systems.
That's all for now, folks. Please like, share, and subscribe to help fund this channel.